video, these are notes on inverse trig graphs. So there's actually 9 different graphs in this unit. There's the graphs of sine, cosine, tangent, the 3 reciprocal functions, cosecant, secant, and cotangent. So you have the original 3, the OGs. You have the OG, you have the reciprocal, and then you have the inverse. Okay, so there's 3, and we never do the inverse of the reciprocal. Reciprocal of O, inverse of OGs. Okay, so these are 3 brand new graphs we're going to learn in one lecture. Oh boy. So how do I find, so write the date. How do I find any inverse? Well, you switch, so inverse, you switch X and Y. Now to graph, I'm going to graph my original. So to graph inverse sine, or arc sine, those are synonyms, I'm going to graph sine and switch the X and Y of each point. So let me graph sine pretty carefully here. So this is sine. Okay. So 1, 2, 3, 4, broken in quarters, okay, highest and lowest. So this is sine, 0, 0. Okay, so let's label these. The labeling will be important. So this is 2 pi. Halfway is pi. Half of that is pi over 2. And this is always 3 times this length. So 3 times pi over 2 is 3 pi over 2. Okay, if you need to pause to get those labels down, please do. So my 5 key points of sine, it starts as midline and goes up from there. Boink, boink, boink. Looks like this. Okay, and it keeps on going, right? Okay. So now, again, if you need to pause to get that down, please do. So now let's do the inverse of sine. So I'm going to graph, both of these are the same question, okay? Graph inverse sine or graph arc sine. So I notice here that my x-axis is what sine wraps around. So when I switch x and y, my x-axis is going to become my y-axis. So x-axis and y-axis switch. So if sine wraps around the x-axis, inverse sine is going to wrap around the y-axis. So I'm going to do a long y-axis. Normally I don't need much of a y-axis, so I don't need much, in this case for the inverse, I don't need much of an x-axis. Or actually this is theta, right? Okay, so let's start doing it. So this is the point 0, 0. If I reverse 0, 0, I get 0, 0. Not so bad. This is the point pi over 2, 1. If I reverse that point, like if I take the inverse of that point, more specifically, reverse could mean a few different things. The inverse of that point would be 1, pi over 2. So these are points on inverse. So I have 0, 0, and I have 1, pi over 2 so far. Okay, so 1, and I'll just assign pi over 2 there. Okay, now here, let's find other points. So here's the point pi, 0. So the point on the inverse function, this is a v. The point on the inverse function is, so pi, 0, the inverse point would be 0, pi. So let's chart that, 0, pi. So this is pi over 2, pi would be twice that distance, so right here, or the same distance again. Okay, now here I have this point is 3 pi over 2, -1, right? Is this point? So the inverse point would be -1, 3 pi over 2. Okay. I didn't mark this on here. So 0 pi, boom. Now -1, I'll put a -1 here. 3 pi over 2, I'll put there. -1, 3 pi over, -1, 3 pi over 2 will be here. Okay, so I have 1, 2, 3, 4. I need 5 key points for sine, also for inverse cosine, for inverse sine. So the last point is 2 pi, comma 0. So my inverse point would be 0, comma 2 pi, right? So 2 pi will be here. So basically, instead of splitting into quarters, my x-axis, I'm taking my y-axis and splitting it into quarters. And now I'll just graph it. Okay, and then I'll just keep it going like that, look like that, right? Cool, so you see how it wraps around the y-axis? If I were to keep going, it would look like like that, you know? It would just keep wrapping around the y-axis. So this would not be periodic, but periodic means if you move, you can only move it left and right to be the same. So having different outputs or different y values or moving up or down is not allowed for a periodic graph. So this is not periodic. Anyway, so, I use this. So that's inverse. That's also arc sine, just to be clear. So I use this word relation. Why did I use the word relation and not the word function here? Why did I use the word relation, not function? Yeah, so why I did that is because this is not a function. Because every x value does have multiple y values. It actually has infinite amounts. So if I just drew a vertical line at a certain x value, like -1/2, it has a whole bunch of different y values, right? Yeah, this would be a, let's see, 5 pi over 4, etc. Yeah. So if I wanted to do a function, what I would need to do to this, like let's think, how could I chop some of this off, okay, to make it a function? Would I squish it this way? Would I squish it that way? Like where would I do the chopping? Would I chop out the domain, or would I cut off the range? And what's an example of a sample domain or range that would work to make this be a function? Okay, so let's see. I'm going to do, so the spoiler alert, the answer is -pi over 2 to pi over 2. That's how I'm going to limit the domain. The range, rather. Limit the range. So if I limit the domain, I still have things on top of each other. But if I limit the range, I don't. So if I do this, okay, once I pass pi over 2, if I keep going, I have an x value with the same 2 different outputs. Or with 2 different outputs. Same x, 2 different outputs. So that's a problem. Okay. But if I go, so I have to stop right here at pi over 2. I'm going to say that again. This I'm good, but once I start going, I have a single x value with 2 different y values. That's a problem. Okay, if I go this way, am I on top? Am I on top of itself? No, not yet. Not yet. Okay. Now if I keep going, just gonna make this look nicer. If I keep going, see how this would be exactly have the same x value would have 2 different y values, so that's a problem. So I'm going to limit limit range to, and I can include the endpoints, okay? So I'm going to say limit range to negative pi over 2 to pi over 2. You could also say negative pi over 2 is less than or equal to y. It's less than or equal to pi over 2. And so let's see what a graph of the function would look like. Okay. Okay, let's just set that up. So I've limited my range. It would look like this. That's it. And you can see now that that looks like a function. But if I were to keep going like that, it wouldn't be. Okay, so that is the graph of inverse sine, the function. Now the notation we use to distinguish between each two is lowercase s is the relation. And if I write it with an uppercase s, that means the function with the limited range. Okay, it means the function with the limited range. Alrighty, let's move on to cosine, okay? So I'm going to graph cosine. I'll do it this one like a little quicker. Dink, 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 dink with my little, okay. So I learned last time, instead of making my cosine, just like sine, they're both sinusoidal functions, right? Cosine wraps around the x-axis, so its inverse is going to wrap around the y-axis. Okay, so inverse is going to wrap around the y-axis. This is 0, 1, which will go to 1, 0. And so, like, my little shortcut kind of is, and normally I make my quadrants here on the x-axis. I'm going to divide my y-axis into quarters. So there's nice even quarters. And then I just make it wrap around the y. So I like to actually transform this point by hand, 0, 1, because sometimes I like look at it on this side, you know, I don't know. Sometimes I get it wrong. So I transform that point by hand, and then I do the shape from there. Boink. Well, my key points and then the shape. So those are my key points. So the V is like this. So it's reflected across the line. Y equals x is also how you find inverses. Like that. A little something like that. So that is inverse cosine. So this is, and I should label something on the y-axis. I'll do 2 pi, that's good. Okay. This is x, this is y. Technically this would be theta, right? So my theta axis. Okay, so now this is clearly a relation because given x values have different y values, outputs, actually an infinite number amount, and keep on going, right? So how could I limit the domain or range of this such that it's a function, but I don't cut out any more than I need to? So how could I limit the domain or range of this so that it's a function? Okay, so I would have to limit the range, and if I chopped it off, like started here and ended here, so if I just took this part, okay, if I just took this part, that's a function. If I went any more, I would start going under or on top of myself. So I'd limit the range from 0 to pi. Or in other words, from 0 less than y, less than or equal to pi. So I'm going to graph the function capital inverse cosine. By the way, just FYI, when you say this, you never pronounce this cosine to the -1. You always pronounce it just inverse cosine. Okay. So the relation, I would have 1, pi over 2, and pi. So I'm just going -1, okay? So why don't you try to graph that. Maybe pause the video, graph it. Okay. Alrighty, that would be the function capital inverse cosine of x. Remember, sometimes these are easy to get them confused. If you know the graph of cosine, you can always graph cosine and then just switch the x and y values. Legit always, okay? All right, let's keep going. We got the graph of inverse tangent, also arctan, and we're gonna have the same thing where we're gonna have a relation and a function, so. Alrighty, so we got, let's do tangent. So the period is just pi for tangent, recall, and there's only 3 key features. It starts and ends on its midline. Tangent starts and ends on its midline, and halfway through its period is an asymptote. Boink, 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 boink. Okay, if you want to graph the point pi over 4, 1, it's a great point to plot. All right, and then it would keep going, right? Like that, okay. So I'm gonna graph these 3 features. I'm gonna switch the x and y. So this is 0, 0, whose inverse will go to 0, 0. Look at me switching the x and y. So difficult. I'm gonna label this inverse tangent theta, okay? So this other point, okay, my next key point is pi, 0. right? Which will go to 0, comma pi. And then my asymptote is always halfway between, let me put a big point there. My asymptote is always halfway between my 2 key points. So these are my key points. My asymptote is right here. If I were to make the equation of this asymptote, I would say it is theta, or x, equals, I'll just use x to simplify it, okay? So x equals pi over 2. So the inverse would be y equals pi over 2. In other words, right here. Another thing we might recall from learning about rationals is that vertical for the inverse goes to horizontal, okay? And then you do it here. And also something tricky that can be about inverses, the first quadrant actually goes to the first quadrant, because if you have positive, comma, positive, when you switch the signs, it goes to positive, comma, positive. So Q1 points also go to Q1. So if I'm starting in quadrant 1 here, for the inverse, I'm going to also start in quadrant 1. Okay, right here, okay, for this part, that is Q4. So Q4 would be positive, comma, negative, which would go to negative, comma, positive, which is Q2. So this Q4 is going to go to Q2. Check it out. This is me in Q2, right? Oh. All right, so that is well, it's not a period because it's the inverse, but it's an inverse of 1 period of it. And I'm going to do, so if this is pi, I'm going to do another period, 2 pi, with my asymptote halfway between. Here. Okay, and I'll do another period. So this is pi. This will be negative pi. A little bit of that. Okay. And it would keep going. So that is inverse tangent. Now to make this a function, all right, I want you to think, would you limit the domain or range, and to what? Would you limit the domain or range, and to what? Okay, so if you limited the range so that you're just looking at this part, okay? Here, I'll zoom in a little bit. So you're just looking at this, that one thing, that would work. Nothing's on top of itself. There's no x that has multiple outputs that are different. So you want to limit the range to go from negative pi over 2 to pi over 2. This is just like sine, which is not coincidental because they're both odd functions. So since they're both centered around the origin and this range is centered around the origin, that's why it's not a coincidence that you limit the range in the same way as sine. Okay, so to draw to draw as a function, theta, capital inverse tangent of theta. Okay, I'm going to go from negative pi over 2 to pi over 2. I'm here, and I have my asymptote. It's kind of weird that we're not doing the 2 points with the asymptote in between. I'm actually doing the 2 asymptotes with the point in between. Alrighty, and that is the graph of inverse capital tangent of theta. Okay, thank you very much for your attention. And this is Ms. Schultz signing off. Okay, bye.